We're going to spend our algebra review doing systems of equations. So this will be our first day. There are 3 ways that we can solve systems of equations, and they are graphing, substitution, and elimination. Remember that the solution to any system of equation is the point where the 2 lines intersect. So for graphing today, which is what we're going to be focused on for day 1, we are going to graph both lines carefully, and we are going to make sure that we use a straight edge, a ruler, and then the solution or the answer is where the 2 lines intersect. So we're going to give that ordered pair for the solution. Now, what if the 2 lines don't touch? What if they're parallel? So we would put no solution. We also have a third option when they're the same line. We would say infinite solutions because it's like one line right directly over the other line. And so it's touching at so many different points that it is infinite. So those are kind of our 3 options. Most of the time we will see one of these 2 though. So we're going to practice with these first 3 examples together. So here's our first equation. And remember that this is my slope, y equals mx plus b, and this is my y-intercept. So I'm going to go ahead and start b for begin at 2. And again, I always start on the y-axis. And so I'm going to put a dot at 2. I'm going to then rise 4 and run 3. So remember that slope is rise over run. And a positive slope is going to go up from left to right. So I can see this is a positive slope. So I know it's going to go up from left to right. So up, 1, 2, 3, 4, and right, 1, 2, 3. So now I'm going to go ahead and use my straight edge, and I'm going to draw a line. And I'm going to go ahead and do the same thing for my next line. So again, B for begin at -1 on the y-axis each time, always on that y-axis, the up or down axis. And then we're going to rise 1 and run 3. So up 1 and right 1, 2, 3. And I'm going to repeat that again, up 1 over 3. The more dots we have, the more accurate our line is, and we want to get as accurate as we can. And now when we use our straight edge, we can see if we're off just a little bit, we're not going to be able to see where they touch. It's going to be kind of hard to tell. But straight lines, we see it touches right there. And what are the coordinates of that? That's -3, -2. These are negative. You can't really see because the line is covering up the negative, but -3, -2 is our solution where they touch. All right, let's go ahead and take a look at B. So this one, we have our M, we have our B. M is actually, there's a 1 in front here, right? And then any whole number is always over 1. So our slope for this is actually -1 over 1. So when we start here at -1 for our B, we're going to go down 1, right 1, and again, down 1, right 1, down 1, right 1. And then we can go ahead and draw our line. Through those points. So for our second line, B for begin, M for move, y equals mx plus b, right? Y equals mx plus b. B is our y-intercept. That's always our starting point, begin. And then this is our slope, which again is rise over run. All right, so -4, put a dot. This time the 2 is over 1, right? All whole numbers go over 1. And so we're going to go up 2 and right 1. Up 2 over 1. Oh, and we can see right where we touch there. If I can get accurate here. Again, I can't do a straight edge on mine, so hopefully you are using a straight edge on yours. But right there, we are touching at 1, -2. All right, so then our third example here. Again, we have a 1 in front when we don't see a number, and it's over 1. So up 1, over 1, after we start at -1 with our beginning dot. And again, up 1 and right 1 for our slope. And use your ruler. get a straight line. And then our second one, we're going to begin at 4. And we are going to go, this negative is in front, so I'm going to go ahead and give the negative to the top number. We don't give it to both, but we give it to one of them. So now I'm going to go down 1 and right 4. So down 1 and right 4. If I couldn't go down 1 and right 4, then I would do this one. I would give that to the bottom, and I'd go up and left, which is going to actually give me the same exact line. If you'll notice, see, I'm still on the same line. It's just a different way to get our second point. And we touch right here at 4, 3. All right, you are going to go ahead and complete these examples here. We're going to go ahead and do number 2 together, but you're going to complete all the rest of those 5 examples. So let's take a look at number 2, our last one together from your homework. So pause the video if you want to try this one on your own, and then you can push play to check. Or if you want to follow along, we can just go ahead and do it and keep it playing. So we're going to graph this first one here. Again, all whole numbers are over 1. And we're going to begin at -1. And we're going to go down 3, 1, 2, 3, because it's -3, and right 1 for +1. And then we are going to go ahead and draw our line. And then our second line, we are going to begin at 2. Again, on the y-axis, always starting there, and down 3 over 1. So notice that we do not touch. So remember, when we do not touch, they're parallel, so the answer is no solution. Parallel is just the description, it's not the actual answer. The answer is there is no solution because they don't touch. All right, go ahead and try these other examples. Put your 1 over 1. Any whole numbers, make sure that you put over 1. Any ones you see no number in front there, the coefficient is 1. And then go ahead and start on your y-axis and start graphing. See where they touch. Use your ruler.